photo. This is the mass number. This is the element number. Atomic number. I might give you this photo on the exam and I might ask you which one is atomic number, and you don't want to tell me that this is the atomic number, this is the mass number. So just make sure you guys know which one is which. These are some shell models for educational purposes. This is not what it actually looks like. And then definition of ion. So anything with a charge, positive charge or a negative charge. And we will today apply these definitions. And then the chemical bonds. And in the video, I said that I need you guys to know 3 types of bonds, and that's covalent, ionic, and hydrogen. Covalent bond is when 2 atoms are sharing a pair of electrons. And then ionic bond, actually, before I go over that, polar covalent bond is really, really important. It's going to be positively charged and it's going to be slightly negatively charged. And the example is water molecule. This is really important. Water is universal solvent, and we're going to discuss that today. This chart here shows you the common name, chemical name, and then chemical formula. And then these are different ways you can write these out or draw these. Okay, so I'm gonna start here, ionic bond. Ionic bond is the mutual attraction between opposite charges, so positive and negative. So here is the sodium ion, this is the chloride ion, and they're attracted to each other. It's positive and negative, so opposite. They're attracted to each other. This Na, these names come from Latin and Greek. I'm not sure what the name is for Na, but if a person has low sodium, they're hyponatremic. And if they have high sodium, they're hypernatremic. And these are the chemical names, and then it gives you this, that's table salt. So that's ionic bond. So ionic bonds are positively charged, slightly positively charged, and slightly negatively charged. So polarity is any separation in charges here. So one end is positively charged, other is negatively charged. They're attracted to each other. There is a strong attraction, so it's a strong bond, and that's ionic bond. This is another way to draw it. So this is sodium, this is chloride, and they form an ionic bond. Okay, so here, this is showing sodium, this is showing chloride. And then we talked about water being a polar molecule. So you have oxygen here, and then you have 2 hydrogens. What you can see on this photo, water molecules are getting in between sodium and chloride. And it's gonna break it apart. And I said water is a universal solvent. That means everything is gonna dissolve in water. And if you put some oil droplet, it's gonna be there. It's not gonna, dissolve. But if you leave it there for maybe hundreds of years, eventually it's going to dissolve. Yes, Kellen. So do you need me to go back to any of the slides?
Can you say one more time a thing about like the high amount of sodium? Like if we have like a large amount of sodium inside, it will be like hypo something?
Oh, that's just if you're using medical terms, if person has high sodium, they're hyponatremic. You don't have to know the term. I was just giving an example. It's medical term they use. And if they have low sodium, usually most people these days have high sodium because everything we eat has large amount of sodium. They're hypo. So hypo means low, hyper means high. Natremic is just a word for sodium. So I was just trying to tell you why they use Na for sodium for that. Okay, good. Ionic bonds, okay. You need this slide, Kellen. So ionic bond is positively charged. One ion is positively charged, one element here, and the other one is negatively charged, and opposites attract. And they form a very strong attraction towards each other. And the bond that forms because of that is called ionic bond. So that would be the definition if you wanted to define that. And then polarity is referring to any separation in charges. If it's positive and negative, there is a separation in charges. That's polarity. So I was talking about this slide. So I said this is sodium, this is chloride, sodium chloride, table salt. When they're together, they're attracted to each other. They are making an ionic bond. They are known as table salt, right? But if the water start to slip in between, these are water molecules. They're going to start breaking them apart, and it's going to dissolve in water. If you put table salt in water, those water molecules get in between these, and this dissolves in water. So that's what this is showing. So all living organisms are mostly water. We're water, and water is essential for life here on Earth. So all chemical reactions of life are carried out in water. So what I'm trying to say is water is really, really important. If there was no water, life would not exist. And the third kind of bond that I need you guys to know, so I said covalent, that's when sharing of electron is happening. Then I said ionic, that's when opposites are attracting, positive and negative. And the third kind is hydrogen bond. That's going to be found in water. So that's the third kind I need you guys to know. I want you to write this down. Hydrogen bonds are weak bonds. They are not very strong bonds, they're weak bonds. Ionic bond is a strong bond. So here, this is showing a water molecule. You can see slight negative charge here and slight positive charge here. And sometimes what happens is that hydrogen from this water molecule makes a bond with this oxygen. So that's a hydrogen bond. It's a very weak bond. It's gonna break very easily, but this is what happens in water. If you glass of water, some of those hydrogens gonna make a bond with oxygen. So it's a hydrogen bond. And when that happens, it's going to give you surface tension. So hydrogen bond's gonna create surface tension. So I'm gonna show you some examples of those in a second. Here, this picture, this is a DNA molecule. These are the bases, adenine, thymine, guanine, cytosine. Don't worry, you don't have to know the names just yet. When we get to the DNA chapter, you'll have to know the names. But these bases, they're held together with these dots. These dots are hydrogen bonds. And I said these are weak bonds. And you guys, hopefully you guys know that DNA replication happens. And when that needs to happen, these bonds break because they're weak bonds. They break easily and the strand opens and then the information gets copied. So if these were very strong bond, that would be very hard to do. So because they're weak bond, they break easily and the information can be copied. So water has some unique properties. Actually, before I do that, let me show you some examples of surface tension. So if you have a coin and you start adding water to that coin, before it runs over, it's gonna start collecting on top, basically, if you adding drop by drop. And that surface tension is those weak hydrogen bonds keeping it together. And if you go to International Space Station and you throw a drop of water in air, it's not gonna explode. It's gonna basically turn into a ball. Those hydrogen bonds just keep it together. So this is because there's no gravity. There's nothing taking them apart. Also, some insects can walk on water, and that's because of surface tension. So here, if you see, they can walk on water. It's called walking on water, and that's because of those hydrogen bonds. So that's surface tension. And then another thing, if you have your coffee cup or your water, and you're gonna notice, if you look very, very carefully, that the water starts to rise up on the sides compared to middle part here. So it's gonna start rising up on the sides more. And that's again due to hydrogen bonds. Hydrogen bonds give it very unique properties. So bonds in water, hydrogen bonds in water. One thing we said, it gives it capacity to dissolve many things. Water has that capacity. And another term that I want you guys to know is cohesion. So surface tension, I just showed you what that is. Cohesion is just the ability for those molecules to stick together. So when they stick together, that's cohesion, giving it surface tension. Another thing, another property of water is temperature stability. Any cities, for example, San Francisco, if they're next to a large body of water, if there's water nearby, it's going to prevent it's going to prevent drastic temperature changes. If you think about it, it takes really long time to bring water to boiling temperature. Oscar, do you have a question?
Yeah, I have a question about cohesion or surface tension. Is that only applicable to water?
Surface tension is applicable to water. Cohesion is it's applied to all the liquid, all
Okay, thank
types of liquid. Yeah. So if it's next to a large body of water, it can absorb heat. Water can absorb heat. And in San Francisco, the temperature stays around 60 degrees, doesn't get too hot when it's summer. So it doesn't move much. The temperature there's no large change in temperature, whereas maybe in Fresno, there's no water nearby. It gets really, really hot when, during summertime, or it gets really cold when it's winter. So water can absorb heat, and it's going to provide temperature stability. And if you really wanted to know, what the temperature would be like if there was no water, planet Venus, there is no water, and the temperature during the day gets to 800 degrees. And if you go near your oven and it's at 500 degrees, it's really, really, really hot. So you can just imagine how hot that can get. And at night, it's gonna it gets around, I think, negative 100. So it's really cold and it's really, really hot. So some more vocabulary, again, do Quizlet for this or do flashcards. We have a term called hydrophilic. Philic means water loving. They like water. So it's a substance that's going to easily dissolve in water. For example, salt or sugar. So that's hydrophilic. Then we have hydrophobic. Phobic means fearing. So phobia, water fearing. They don't like water. So it's a substance that resists dissolving in water. And in this photo, you can see oil. If you put a droplet of oil, it's not going to dissolve. But like I said earlier, if you leave it there for hundreds of years, eventually it's going to dissolve. So those are two terms.